Zoltan Balazs, speaking on sandbox detection, leak abuse test. If you give him applause.
Hi, everyone. How many of you know techniques to detect malware analysis sandboxes? Hands up. OK, that's great. So this is my name. This is where I work. And I'm from Hungary. And we are a very small country, so we are very proud of our achievements. For example, did you know that the Rubik's Cube has been invented by a Hungarian guy 40 years ago? Also, the idea of a phone exchange system was from a Hungarian guy. One of the developers of Visual Basic was Hungarian. And last but not least, Pipach, who is very famous for his Linux hardening security patches, and he achieved a Lifetime Achievement Award at DEF CON. He's also a Hungarian guy. So we have a lot of very cool guys in Hungary. These are the things I'm personally proud about. I'm the developer of the Zombie Browser toolkit. I have created the hardware firewall bypass tool. You can see the presentation about that on Friday from me. And I also implemented some ideas how one can bypass the exploit detection of appliances. Unfortunately, some of the bad guys read my blog, so they also implemented my idea. But I think being on the offensive side helps the evolution of security. So this is not a bad thing at all. I have a very fun cyber game for you today. And you should look for one of these words on the slides. And whenever you see cyberphobia or cybergeddon or something with cyber on the slides, just shout that's cyber, and you can get a real Hungarian Rubik's Cube from Hungary. No, from now on. All right. So how many of you guys are penetration testers and wrote at least once in your life malware during penetration test? Hands up. OK. How many of you guys are developing new malware analysis sandbox? Hands up. OK, not many people. How many of you guys had analyzed malware in your environment and you saw that your malware was not running in the sandbox and you had no idea why? OK, quite a few people. Good. Or how many of you are on the defensive side and trying to buy one of these new shiny appliances which promise ape detection and things like that? OK, great. So you might know that the current malware analysis world can be divided into three parts. Static automated tests, where the malware is not started and something just looks at the code, how it looks like at the binary, and it will decide whether it's malicious or not. For example, the old antivirus engines did that, or now these next generation thingies. There is the dynamic automated analysis, and my talk will be about how you can bypass these dynamic automated analyses when someone starts the malware in an environment and it looks for suspicious behavior like stealing some files, connecting to a CNC server, things like that. And last but not least, we have a lot of manual analysts, but unfortunately, there are a lot more new malware code daily than the malware analysts can keep up. So even it is very, very hard to deceive or bypass a real talented malware analyst who is doing manual analysis, but it's still sometimes possible, but it's very hard work. So the name Sandbox is a little bit confusing, so I know at least about 3 different sandboxes. This is not the sandbox I'm going to talk about today. There are browsers, for example, which implement Sandbox, for example, Chrome. I'm not going to talk about these kind of sandboxes. I'm going to talk about sandboxes which do malware analysis. We call them breach detection system or advanced persistent threat detector or whatever catchy name they have. The main idea is that there is malware coming inside the box. The box does its magic, and you get an alert or a report that this is malicious or not. So you might see that sometimes I'm a bit sarcastic about these appliances, and actually I don't have any problems with the technology itself. My problem is usually the marketing department or the price of these appliances compared to the real value. You have to know that there are some really good malware analysis appliances out there, but not all of them. And it is very hard to compare these things. Actually, 2 years ago, me and some of my colleagues at Crisis Lab, you might have heard about them, had the idea to create 4 new malware and test it against these malware analysis sandboxes. And actually, we created a very basic malware with a script kiddie level, 2 medium ones, and 1 advanced malware. We developed as a small team in 1 week, and that advanced malware bypassed all the high-end malware analysis sandboxes. So it is room for improvement, I would say. Also, if you look at the price of these appliances, it can be very expensive. So whenever you are trying to convince management to buy one of these boxes, you can even try them to convince to buy this company car for you. You can decide which is better for you. I would go for the car. So let's meet the hero of the hour. I call him Trevor. And Trevor is the Chief of Information Security Officer at Acme Corporation. And Trevor has a problem. He knows that his current defenses are bypassed, whether it's AV or IDS, IPS, whatever. And he has the money. He wants to do something, but he has no idea what to do. And he is contacted by different vendors. And these vendors tell him that, hey, we detected the most zero-day exploits last year. We are the best on the market. Other vendors can say, we are the most expensive, so you can be sure we are the best. Or other vendor marketing department can say that we are the cheapest, so you can be still compliant and save some money. So for Trevor, it is a very hard decision which vendor to choose. So Trevor is very sad and he don't know what to do. So I was thinking about how about testing these malware analysis sandboxes. And it is very important to say that there are thousands of aspects how you can test these malware analysis sandboxes. And I'm only covering a very small part of it. Malware authors know for a long time that if they can evade these dynamic analysis, then they can evade detection for a longer time. So they have implemented tricks to detect these malware analysis sandboxes. So my research was focusing on this area, and I have checked the known techniques, how you can detect these sandboxes, and I also implemented my idea, and you will see how these different techniques worked against these APT detectors. But you have to see that if a very lame and common malware can evade this APT detector, then what an intelligence agency can do. So if you are a penetration tester, why is it important to not getting detected by these malware analysis sandboxes? First of all, your code won't get busted on day 1. And you can continue working and doing lateral movement, privilege escalation, and so on. From a developer point of view, it is also a very good idea that if you can reuse your malware during engagements and you don't have to write new malware from scratch. So, how many of you guys are Command and Conquer fans? All right, very good. If you want to attack the other team, what do? First thing, send out a scout, yeah, right? You want to know what's happening inside his base. You just don't shoot everywhere. At the beginning of the game, you have this very basic trooper. At the end of the game, you can have the spy plane, which is kind of cool. But one thing is sure, if you have the atomic bomb, you just don't drop randomly on the map, right? You know where your target is, you have mapped his infrastructure, and you send it where you can really make damage. So as I mentioned, detecting malware analysis sandboxes, it's not a new idea. But as I have seen in the past, there is too much focus on virtualization detection. Doing virtualization in a malware analysis sandbox is pretty common because you want to save money. And it's not a problem at all. But nowadays, most of these malware analysis sandboxes, they don't act like virtualized environments. So even if, I think I will tell about this later, but the biggest issue is that there is a very limited list how you can find out that malware is running inside the virtualized environment. And if you use these known techniques to detect it, then your malware will be flagged as malicious because it's trying to detect the virtualized environment. So it might have worked in the past, but I'm pretty sure it won't work nowadays. Let me tell you a very small example. On the left, you can see a very common RAT, remote access Trojan. Yes, CyberGate. It was not, sorry. It was not written on the first slide. You have to look for that specific one, but good catch. You can have the half of the Rubik's Cube. So, and here, when you are creating your Trojan, you can click so you can evade all of these sandboxes like VMware or Anubis or CV Sandbox, Jobox. It's a pretty old one, but it worked at the time. But nowadays, there are endpoint protection systems which do this so-called vaccination technique. And it creates an environment for processes that it looks like it is a virtualized environment, but it is not. It can be any notebook or desktop. And whenever this malware is trying to detect this virtualized environment, this endpoint protection system will fake it. It is a virtualized environment, so the malware code will quit. And also, meanwhile, because it's monitoring this event, it can kill the malware and alert and so on. So detecting virtualization is not a good idea. I'm pretty sure you all heard about the hacking team leak. It was a very good treasure, I would say, and reading all things what they did there. So if you check what hacking team did, they are also doing this kind of attack where first they send a very tiny piece of malware. This malware checks the environment like CPU architecture, RAM installed application, and so on and so on. And then it sends this information to the server. At the server, they decide whether this is their real target or not. And if it's the real target, then they will upgrade this scout to an elite or a sniper agent, soldier, sorry. But they are also doing this VMware and VirtualBox detection, which is kind of stupid. I'm sure you cannot see the code here, but I have also written there. Actually, they have implemented new ways to detect virtualization, but not the best way. For example, there is a very great project on GitHub called VBox Hardened Loader. And if you use this VirtualBox, patched VirtualBox, this code won't detect that it is running inside a virtualized environment. I myself using this VBox Hardened Loader project for malware analysis. It's a free and very good program. Now, let's talk what I have created. I have developed a piece of malware, which I upload somehow to these malware analysis sandboxes. The malware checks the environment it is running inside, and it will extract all the interesting information and send it to my server. There are different ways how you can extract this information. For example, the easiest way, if there is a direct internet connection from the sandbox to the internet. In that way, I can easily post any environment data to my server. Or sometimes there is no direct connection, but the malware analysis sandbox is resolving the host names to IP addresses. And here I did this DNS tunnel trick. So let's say I'm controlling the attacker.com domain. And whenever my malware checks what is the IP address for the host name, Microsoft Office is installed on this computer.attacker.com. This query will go through all the DNS servers to my server, so I will know that Microsoft Office is installed on that computer. Sometimes I have used the reports to leak this information. For example, sometimes it creates screenshots, so I can put all the information and on the screenshots. Or sometimes I have created new files with special file names, like Microsoft Office is installed.exe. So there are many, many ways how you can leak data from these sandboxes. Unfortunately, I'm not going to show you any live demo today, but I have a small video about this. So here you can see a free, very basic malware analysis sandbox called Malware. It's based on Cuckoo. Sometimes I use it. It's a good service, and it's free. And here you can see that I have uploaded my malware to this malware analysis sandbox. Now let's see what I can see on my attacker server. Here you can see that the malware started to run, and it is leaking all the different information to my server. For example, you can see that the video BIOS version is VirtualBox. What else? You can see here that it is a Xeon processor. Here you can see it is moving the mouse. So a lot of different information can be found in my server. And now, if we check the report, what happened here, then you will see that it flagged my malware as malicious because I was doing too many things. Here you can see that it contacted 2 domains. And here you can see that, for example, it collects information to fingerprint the system, which is true. I did that. So one very important thing is that when you try to detect the malware analysis sandbox, you shouldn't really use too much checks, because too much checks can be noisy. So you better implement a few, but better checks. I have uploaded my malware to maybe 60 different sandboxes. And I have created statistics how the different sandbox detection techniques worked. And I will use these two small icons on the next slides about the effectiveness. So if you see this big red icon, it means it is a good, effective, and so very malicious sandbox detection effectiveness. But if you see this big trap, it means that it is very easy to catch this technique. If the red icon is small, it means it's not a very effective technique to detect sandboxes. And if the trap is small, it means that sandboxes cannot really detect this technique. First and easiest technique was check for screen resolution. On the top, you can see statistics from browsers. And as you can see, only 7% of the users used these small resolutions. And it is a very interesting technique because you can even do this screen resolution detection even from the browser itself. So if we are talking about exploit kits, it is very easy to detect this is a sandbox at the very beginning of the attack. And the results were that almost 80% of the sandboxes used very, very low resolution. I mean, I have no idea who's using 640 multiplied 480 screen resolution on his desktop, but some of the malware analysts did. So it is a quite huge problem. But as you can see, there were sandboxes which used very high resolution, which is good. Next, I checked for the installed software. And here I have listed some of the softwares which you usually don't find on a typical desktop. And the last one is the most interesting one, because it was VEWare tools. And the story behind this that some malware checked for the string VMware tools. So the sandbox developers tried to bypass this, and they renamed VMware tools to VEWare tools. But if you are leaking this data to a server and check it manually, you can be 100% sure that this is not a desktop. This is a malware analysis environment. I have also checked the running processes. I'm not sure you can see dumper or fake server on any real desktop. I have also checked the CPU type, and this turned out quite interesting because usually the fact that this system is virtualized is hidden very well, but they don't fake the processor. So if you are attacking, for example, desktop users through the browser, you can be sure that it is not a Xeon processor, right? Or a quad-core Opteron or whatever. What's strange that I have found some Pentium Pro and Pentium 2 processors. I have no idea what's going on there. But again, there were some sandboxes which either faked or were really using desktop CPUs like Atom or Core 2 Duo. So this technique turned out to be a very effective one. It is also a known technique to check for the number of cores dedicated to the system. And unfortunately, most of the free sandboxes use only one core, which is not common in a new modern desktop. But I have seen, for example, a sandbox in Ukraine which were using 4 cores. That was pretty cool. I have also checked the computer system. It's more or less virtualization detection, but again, this turned out to be very interesting. For example, if you see Box or KVM, you can be sure that this is a malware analysis sandbox. And here again, I saw that this kind of information is not faked or simulated, by the sandboxes at all. So you can see a lot of server platform. And again, if you know that your target is on a desktop, you can be sure that the server platform is not your target. A very old technique is to check for the mouse movement. And it turned out that 80% of the sandboxes had no mouse movement at all, and only 20% simulated the mouse movement. Also, it was easy to catch that some of the coordinates were not very human-like, like 0, 0. I also checked for the RAM size, because nowadays no one can use the internet with 2 GB of RAM. And it turned out that, again, most of these sandboxes are using very small amount of RAM. But again, there were some good sandboxes which used, for example, 4 GB of RAM. So it's not the best way to detect sandboxes, but it's a good one. I have also checked the machine name. Yeah, exactly. You can decide whoever wants the Rubik's Cube best. Okay. So I did this just for fun, but naming your sandbox as Sandbox A or WinXP Maltest is not the best idea. But if you really know your target and you hard code the machine name in your malware, it will only run on that machine. That can be very powerful. I will share my slides with you at the end of the presentation. And I have a whole lot of collection of malware analysis sandboxes screenshots. This is one of them. And I need your help to analyze with me why this is a malware analysis sandbox and not a desktop user workstation. Yes? Yes, it's a default background. That's what you are saying, right? Yes, so nobody is using that default background, right? Yeah, no icons on the desktop. Usually it's full. Sorry? I'm sorry, I can't hear you, but I'm sure you are right. Empty recycle bin, exactly. Yeah, old version of Adobe Reader, yes. No, the question mark, I think it's legit, I would say. No, it's a screenshot. So no running applications. So there are so many things happening on this screenshot that you can tell this is not this is a malware analysis sandbox and not a desktop environment. Here they didn't even try to hide anything, what's going on. Again, this is another sandbox. And I think if you are developing a malware analysis sandbox, this is how your sandbox should look like. Actually, this is real screenshot. If you download the hacked team torrent and browse for the administrator cposi and check for the screenshots, you can see a whole bunch of these screenshots that he was very busy hardening their network against the attackers. So if you see this, you can be sure this is a real user. And this is how your malware analysis sandbox should look like. I have also checked for pen drives or flash drives. And I have seen 3 sandboxes. And in these 3 sandboxes, there was only 1 flash drive. And there were no sandboxes at all which had at least 2. If you check a real desktop user, you will see 10 or 20 or 100 or whatever. This is my best technique to check for the printer. And if you filter out the default ones like Windows printers, Adobe or Office, there was no sandbox on the world which had printers attached, but most of the desktop users has. There are a bunch of not effective ways to detect sandboxes. I have also checked for the number of recently modified created files. It turned out to be a good and effective way, but it's quite slow, unfortunately. You can implement your malware analysis sandbox detection techniques in different layers. And best is to implement your decision on the first layer and implement all layers. So for example, you can have an automated decision in the malware itself, which is good because you won't leak the CNC server, but you cannot implement many things here, and also the analyst will know what you are checking for. You can leak some information to the CNC server and do automated decision there, but now you are leaking the CNC server. You can also do things like stealing screenshots for example, days. And after one day, you can decide whether this is a real user workstation or not. But as I said, the best is to implement all and quit on the first detection. There are some very interesting techniques which I think is very hard to solve for sandbox developers. One of the most interesting questions is whether the sleep function is simulated or not. Very old technique is to start the malware execution with a long sleep. If you start it with the long sleep, it will, the sandbox will time out after 5 minutes or 2 minutes, and there will be no malicious behavior at all. So Sandbox is started to simulate the sleep call. So it will say to the malware, hey, 7 days already passed. But the problem here is that I, as a malware developer, can easily detect that the sleep is emulated on this box. What I implemented is I start 2 threads simultaneously. One thread is doing some hard calculations, for example, hashing for hundreds of thousands of time. And the other thread is sleeping. And whenever sleep is simulated or not, the threads will end differently. And by checking which thread ended first, finished the execution first, I will know that sleep is simulated or not. And if it's simulated, I can be sure that this was a sandbox. I have a lot of lessons learned. For example, if you are a malware writer, it is very easy to find out different ways to detect these malware analysis sandboxes. But if you are a sandbox developer, and you are selling your sandbox for hard money, then you should really do research how your sandbox can be detected. And one of my best advice is to dump a real user workstation, sanitize it, like removing all confidential data, and then you should update this real desktop workstation with user activity. So after a good test, I think Trevor can choose wisely which APT detector he wants to buy. So that's all, folks. On the first link, you can download my malware, which I have created. It's open source. You can contact me on Twitter. On a SlideShare, you can see my slides, or you can see also this screenshot collection I had. And last but not least, in Hungary, we have a great hacker conference called Hacktivity. So I invite all of you to come there. It's a very great conference. Thank you for your attention.
So again, if anyone has any questions that they want to ask, if they want to join Zoltan out at the AusCERT booth, you'll have about 9 minutes or so just before the next presentation. Once again, if you can give him a big thank you.